So this is the question. I think it is visible to you all. The question says that there is a double-ended ranging drum shear that unilaterally cuts, means it cuts in the one direction only in a long wall panel, having the following details. So the diameter of the So, are you aware of this question? Are you all aware of this question? Are you all aware of this question? Yes or no? Okay. So, what is happening in this is that there is a double-ended shearer, ranging drum shearer, and that shearer is cutting in only one direction, and then it is retreating back. So, while retreating back, the shearer has following. It takes the following time. It cuts with a rate of the 5 meter per minute, and then it retreats back. It retreats back at the rate of 10 meter per minute. Afterwards, it goes into a maintenance or some type of reoperational delays. Goes into the reoperational delays of about 2 hours. And so this cutting operation, retreating operation, and the operational delay of 2 hours, these all constitute the time spent in the working shift. Okay, these all constitute the time spent in the working shift. So working shift, the duration of the working shift had been of almost 8 hours, and 2 such shifts run during a day. So the question asks, at last the question asks that the number of days that are required to complete the extraction of the panel, means how much days would be required for the extraction of the panel. Okay. So this is what question is asking. So how will we proceed? Can you all solve this question? Means, let me give you around the duration of around 1 minute, and please solve the question and come back. Let's do this with this question. If you are unable to solve it, then we will go back directly to the question and solve it. So if you all are unable to solve it, I have to solve it by myself. Now, question here is, size of panel had been 200 meter cross. So the size of the panel had been 1200 meters into 200 meters into 2.4 meters. So this had been the size of the panel. Okay. Now, if this had been the size of the panel dimension, it means the depth of the panels is 1200 meters, the width of the panel is 200 meters, and the height of the panel is around 2.4 meters. The web depth of shearer is 0.6 meter. Okay. Web depth of the shearer is around 0.6 meter. So depending on the size of the panel, the amount of coal extracted is equal to the 1200 into 200 into 2.4 meter cube. Okay, so this would be the total amount of the coal that one need to extract. Okay, this is the total amount. Now amount of the coal extracted per cut. Amount of coal extracted per cut is 1200 meters. Is 200 is the width, 2.4 is the height, and 0.6. This is the total amount of the coal that needs to be extracted in one. Now this is the total amount of coal, means that is around I think 48 into 6 मीटर क्यूब पर कट, इतना कोयला, ठीक है। तो साइकिल टाइम पर कट, cycle time per cut, that is cycle time is around 5 meter. Cycle time is around cycle time speed is around 5 meter per minute for cutting, ठीक है। तो cycle time is cutting is and distance, so cycle time per cut would be 200 by 5 for cutting time, 200 by 10 meter per minute is for this, plus delay of around 2 hours, that is 120 minutes. So this is the time. This is around 180 minutes is the cycle time per cut. Now, if this is the amount is got, if you got the amount of the coal cut and cycle time per cut, so how much? If we got both of this, then the hourly rate of coal production is, general hourly rate of coal production is of coal production is 288 meter cube per cut upon 180 minute. 180 minute is equal to 3 hours. Okay, so that is equal to 288 by 3. 3 9 27. This is per hour. Okay, number of hours, number of working hours per day कितना था? 8 into 2 hours, that is 16 hours. The total production per day, so total production per day would be 96 into 16 meter cube. ठीक है. Now the total amount of the coal to be extracted is itna, and the amount of coal extracted per day is itna. So amount of coal extracted per day, so 96 into 16 meter cube into number of days of working is equal to total amount of coal to be extracted, that is 1200 into 200 into 2.4. ठीक है. So number of days, let us say this is n. Number of days would be 1200 200 into 2.4 by 96 into 16. So that would be is equal to this is the answer. So number of the days of the total number of days it would be working is around 375 days. So is this question clear to you all? If it is clear, kindly say yes. If it is clear to you all, kindly say yes. Hello. Is this question clear to you all? If it is, kindly say yes. Say yes if it is clear to you. Now let's see this question. This is another question. It is a very good one. Okay. Now what this question says? This question is this question is saying there is a Longwall panel. Okay. The air flows into the Longwall panel at a the air is flowing in the Longwall panel at the rate of 1.2 meter per second through 900-meter long gate road of 2.5 meter height and 3 meter width. The coefficient of friction is 0.02 Newton second square per meter to the power 4. The frictional pressure drop we have to find out between the two gate roadways. Okay. So basically, what the question is saying here is that, let us feel free to discuss this. The question is saying here is that there is a Longwall panel. Okay. And this Longwall panel has a gate road of length 900. One gate road, return gate road is also there. Now the cross section of the gate road is 2.5 meter height of the gate road and 3 meter width. Coefficient of friction, that is basically the friction factor. Okay. Now we have to find a frictional delta P between these two. Between these two means if this is point A and this is point B, then we have to find out the delta P between point A. Okay. We simply know that in this question they have simply thought that the pressure drop in this region is 0 or minimal. Okay. We have to simply find out delta P in these two. We will simply apply the formula del P of AB is equal to now S is the total length of this. Total length of intake and return is 900 into the perimeter, means the peripheral area is known as basically S. So that is the length into the perimeter. Perimeter is okay. So okay. This is whole S. B in our case is 1.2 meter per second. A ठीक है. So K is S is this. Area is this hole. This hole will be this hole will come around 84 Pascal. So delta P in A and B between the two gate rods is around 84 Pascal. So now the delta P around the gate road A, the ends of the gate road, that is between the points A and C, is around delta P of AB by 2. That is 84 by 2. That is around 42 Pascal. So this is how this question will be solved. Is there any doubt in this question? Is there any doubt? Kindly say, if there is no doubt, kindly say yes, or if there is a doubt, kindly report it into the chat. Is there any doubt? If there is no doubt, kindly say so in the chat. Now, this is a question. Yeah. Now there is this question. The question says that there is a data from a borehole log with a collar elevation of around 590 meter RL. Okay. That is the in tabulated tabular form it is given, means at RL of 500 collar. Okay, question number 59 it is. In question number 59, kindly concentrate on. So this is a borehole log. Okay. This is the RL of 590 meter. This place. Now what is saying, the core length is given. Okay. Core length is given. First is 3 meter. Sorry, then is 3 meter, 2 meter, 3 meter, 2 meter, 3 meter, 3 meter. इतना है core length. What the question is saying is that we have to find out the composite grade. Okay, that is calculated with the O using the O of 5 force of 5 meter above and 5 meter below the reference bench of 580 meter. So this is 590 meter and minus 10. 6 Okay. So we have to go on to the level of around 500. Mm, so this level, this level is of the 580 80 meter RL. So the length above is 2 meter, length below is 1 meter. Okay. Now we have to find the composite. We have to find the composite grade to a length above 5 meter, means 22415, means 5 meter above and 5 meter below. 1 2 3 3, like this. So 1 2 3, and in this case this is 2 meter and this is 1 meter remaining. So 2 to 4 and this is 1 meter remaining. Okay. So we have to find out now within the respective grades. Within the respective grades, we will find that within the respective grades, we find that the for first 3 meter it is 40%. For this it is 42%. For the 2 meter it is 41%. For this 3 meter, it is around 43%. For this 2 meter, it is around 42%. For this 3 meter, it is around 41%. And for last 3 meter, it is around 44. Now we have to find out the composite grade of this zone. Okay, composite grade. What we will do? We will do the weighted sum average of this the grade of the grade of this region to find out the composite grade. So the composite grade would be first of all, see this is a 1 meter. 1 meter into 42% plus 2 into 41% plus this is 3 into plus plus so this is upon average length, that is 10 meter. Okay, so now doing this, we will find out the average. We will find out we will find out the average grade of this. So the average grade would be 42 plus 84, 9 4 to 12 plus 2 to the 4, 4 to the 8, 2 8 by 10. That is around 41. Is this clear? So this is how this question needs to be understood and to be solved. ठीक है? तो इस तरह से हम इस क्वेश्चन को सॉल्व करेंगे. Now there is another question. Now there is this another question. It is the PPT here. Average noise level at a working place is 80 dBA for 10 minutes. Okay, and for the next 30 minutes, it is around 60 dBA. So we need to find out the we need to find equivalent noise level for that place. For the period of about 40 minutes. This is basically the formula based question for the average noise level. So yeah, we know एज पर क्वेश्चन क्या है? T1 is around 10 minutes. T2 is around ठीक है. Now I have to find out L equivalent for the whole duration. ठीक है. This is how this question will be solved. Okay, this is of the this is of the average noise level into a particular area, and this is how this question will be solved. This is the log base 10. Actually, when we are writing the log, it is log base 10. So we have to calculate it. We have to calculate the value of this log, the log of this value, and we will find out 74.1 dBA. Okay. So this is how this question will be solved. Now, a big question. This is a big question. I think it is dependent on the strength of the pillar formula from the Binavsky pillar strength formula. And give me a excuse me for 5 minutes. Hello everyone. Hello everyone. Hello. So this is a question that is dependent on the Binavsky pillar strength formula. Now, first of all, learn this question about. So actually, what is happening in this question? The thing that is happening in this question is earlier there was a pillar, intact pillar of around 30-meter width. Okay, 30-meter width pillar, then the depillaring started. Okay, from the board and pillar, and each of the and that square pillar was divided into the 4 stoops, square shaped stoops, equal size. So the Ja's by the strength would be compromised. So this reduction in safety factor in this operation has to be evaluated. This question is asking simply this, simply asking this in terms of the how much the safety factor would be compromised after splitting the pillar. So first of all, we have to find out the strength of the pillar. Formula of strength of pillar. Now, hmm, width of the pillar is around. If we replace half of the gallery width from each side, then the effective width of the pillar was 30. And the height of the working seam was around 3 meters. This is the strength of pillar in case one. Okay. Now, the maximum load it can be up. Okay. Would be strength of pillar into area of the pillar. Hmm. Okay. Now the load on the pillar. Go density of G, depth of the pillar, into effective area that to be on which the load will be distributed would be 35 square meter. So the factor of safety FOS in first case would be strength of the pillar upon load on the pillar. Okay. This is how this whole question will be sorted out. Now similarly we will go out for the second operation when the second case when the pillar was divided in stokes. So case second. Okay. Width was a pillar, individual pillar in this case. 30 minus 5, 30 minus 5 is 25, 25 of 12.5. Hmm. Now load on the pillar, load on maximum load to be borne by the now load on okay. Now FOS in second case. What is FOS in second case? Is maximum load. Okay. Reduction in factor of safety after pillar splitting in formula. Now, del FOS is FOS in first case minus FOS in second case. FOS in first case is now percentage change in FOS is equal to del FOS upon FOS in first case So this is how this whole question would be solved. Okay. So as I have discussed, we have to first find out the strength of the pillar. In the case one, when the pillar was intact, the strength was calculated as 0.64 plus 0.36 into 30. That is the width of the pillar divided by height of the mining, that is 3. This has culminated into the strength of the pillar as 4.24 types of S1. Now the maximum load that is borne by the pillar is the SP1, the strength of the pillar in the first case into the width of the pillar. Okay, into area of the pillar, sorry, that is 30 square. So this is the maximum load that will be borne by the pillar. Now the load on the pillar would be pressure on the pillar, that is rho GH, into the effective area, or which the load on which the load would be distributed, that is around the equal distance from the pillar, that is 2.5 meters on either side. That area would be finally enlarged to 35 square meter, and FOS in the first case would be maximum strength, well, the maximum load on the pillar upon the load that is being positively experienced by the pillar. This has come down to this value. This is a similar case with the case number second. Okay, case number second. When the it was divided into schools, and the FOS in second case was this. Now the change in FOS had been found out to be around 2.023 S1 times by rho GH. Now the percentage change had been found to be around 64.9%. So this is how much there is a difference in the work, in the how much the say factor of safety is compromised once the pillar is divided into the stoops. So I think this is clear. Okay. Now let's move on to the next question. This is. In this, it is saying that the percentage of Fe, there are 5 random samples have been taken, and the percentage of Fe is found out to be this much, as shown in the PPT. They have to, of the mean grade is estimate कर दिया, then I have to find out the standard error of the mean. Okay. This is the standard error in the mean grade. How much it is? Yeah. For that, what you have to do? For that, you have to first you have to find out the mean. That what is the mean? Yeah. So mean. Okay. Standard deviation. Then we have to find the standard deviation. Standard deviation would be yeah. ठीक है. In our case, it would be ठीक है. Now standard error of mean. What is it? What the question is saying here. So this is what the standard array of mean is. Okay, this is how we need to solve it. I think this is clear now. Now we have to move on to the next question. अमाइन वर्ड है, ठीक है. क्वेश्चन क्या कह रहा है? क्वेश्चन क्या है कि अमाइन का वर्ड है, तो डायमेंशन 100 into 2 into 1.2. सो 3 घंटे के अंदर फिल करना हाइड्रोलिक स्टोइंग से. जो मिक्सचर है वो सैंड टू स्लरी रेशियो 0.4 है, लेकिन अगर हम इसको फिल कर रहे हैं तो हम पूरे एरिया को जो फिल करेंगे उसका हाइड्रोलिक फिल फैक्टर जो है एरिया का वो 0.1. इसका मतलब अगर हम मान लीजिए कि 100 यूनिट्स हमें फिल करना तो 90 यूनिट से फिल कर पाएंगे ड्यू टू द ऑपरेशन कॉन्स्टेंट. ठीक है, तो आर्ली कंजम्पशन हमें पानी का पता करना है इस ऑपरेशन. कोई दिक्कत नहीं है, हम इसको आराम से सॉल्व कर सकते हैं. इसको सॉल्व कैसे करेंगे? इसको सॉल्व कैसे करेंगे कि वॉल्यूम ऑफ वॉइड कितना है पहले. तो वॉल्यूम ऑफ वॉइड है हमारा 100 इंटू 1.2 मीटर. कितना है इफेक्टिव वॉल्यूम ऑफ वॉइड कितना है? ठीक है, इतना इतना हो जाएगा. हमें इतना मीटर क्यूब का टोटल स्लरी देना है. ठीक है सर, सैंड है, हमें इतना मीटर क्यूब का देना है. तो टोटल क्वांटिटी ऑफ सैंड फॉर स्टोइंग जो है तो 16 मीटर क्यूब. ठीक है, लेकिन जो सैंड टू स्लरी रेशियो है वो है 0.4. तो सैंड अगर हमें 216 देना है, स्लरी में क्या है, कितना वाटर देना है प्लस कितना सैंड देना है. या सो वाटर का क्वांटिटी हमें कितना चाहिए होगा? ठीक है, अब हमको जो ये वाटर है, हमको जो वाटर हमें चाहिए ना, दिस वाटर along with this mixture, along with the mixture of the sand, we need to fill the void. We need to pump this water along with the sand mixture in a duration of around, time duration जो स्टोरिंग का है वो है around 3 hours. So hourly water consumption कितना होगा? बस दिस इज सिंपल क्वेश्चन. ठीक है, तो hourly water consumption यहाँ से निकलेगा. जो लिखा है क्वेश्चन है ये कंटिन्यूस माइनर है जो कि सर्व करता है 2 शटल कार को ऑफ 12 टन कैपेसिटी ईच. ठीक है, दोनों का 12 टन का कैपेसिटी है. शटल कार 1 शटल कार को बोथ ऑपरेट. टोटल cycle time of around 12 meters and 15 minutes and 12 minutes respectively, which includes the loading time of 8 minutes for each car. The production rate of the continuous miner कितना होगा? तो हमको वो बताना है कि इसका प्रोडक्शन रेट अभी आप कितना कर पाएंगे. ना शटल कार का पहले देखिए, शटल कार का जो कैपेसिटी है कितना है, 12 टन की कैपेसिटी है। ठीक है, टोटल साइकिल टाइम जो है ऑफ शटल कार 1 और शटल कार 2 की जो है वो 12 मिनट और 15 मिनट है, विच इंक्लूड्स अ लोडिंग टाइम ऑफ अराउंड 8 मिनट फॉर ईच शटल कार। ठीक है, लोडिंग टाइम सबका 8 मिनट है। ठीक है, तो द प्रोडक्शन रेट ऑफ द कंटिन्यूअस माइनर इज, तो प्रोडक्शन द लोडिंग रेट कितना हो जाएगा। अब है कि दो शटल कार्स हैं, दो शटल कार्स का टोटल साइकिल टाइम, शटल कार 1 है उसका टोटल साइकिल टाइम हो गया आपका 12 मिनट, शटल कार 2 है उसका टोटल साइकिल टाइम हो गया 15 मिनट। ठीक है, जो लोडिंग टाइम है 1 का 8 मिनट, 8। ठीक है, तो लोडिंग रेट कितना हो जाएगा, लोडिंग रेट आपका आ जाएगा शटल कार का, शटल कार 1 का, सर शटल कार है, ठीक है, जो लोडिंग रेट हो जाएगा इसका शटल कार 1 हो जाएगा लोडिंग रेट फॉर 2 इज, ठीक है। नो इसमें क्या आवरली पूछ रहे थे, the production rate of the continuous miner in ton per hour। अरे यार, इसका मतलब ये है कि ये दोनों शटल का अब जो भी इनका साइकिल टाइम है तो 4 मिनट इसमें 7 मिनट ठीक है, लेकिन लोडिंग रेट इसका है। अब ये लोग कंटिन्यूसली अगर ऑपरेट कर रहे हैं तो इसका मतलब ये है कि शटल का 1 और शटल का 2 का लोडिंग रेट जो है इन लोगों का सेम है 1.5 टन पर मीटर क्यूब। इसका मतलब क्या है, क्योंकि if this is if the continuous miner is running continuously, then it would be producing 1.5 ton of the coal per minute। ठीक है, so the hourly production would be 1.5 ton per minute into 60 minutes। ठीक है, that would be 90 ton per hour it would be producing if the production is going to control। मतलब ऐसा साइकिल टाइम और ऐसा पोजिशनिंग लोडिंग पॉइंट का दोनों शटल कार्स पे डिसाइडेड है कि शटल कार्स हमेशा वहां से लोड लेती रहेंगी। अगर ऐसा होगा तो वो हर सेकंड या हर मिनट जो है 1.5 टन का कोयला प्रोड्यूस करता है, और अगर इस रेट से करेगा तो हर घंटे वो 90 टन कोयला दे। तो बहुत बड़ा क्वेश्चन था, सिंपल थोड़ा क्वेश्चन है।